So okay, so it's recording. And today, as I said in the remind, we're just going to be doing 2 FRQs. And really these 2 are just, they're not as much as like word problems. They're just kind of like straight up calculus, like with the derivatives and stuff like that. And it's just like solving for variables. So that's kind of what Miss Q wanted to focus on, only because like when you have several variables, you can't put it into a calculator. You kind of have to like know how to do it yourself. So that's what we'll be doing today. And as I said, we're going to be doing the 2001 FRQ Q5 and then the 2000 FRQ Q5. And both of them are like just with straight up math, pretty much. I would describe it. And okay, so let's do 2001 Q5. So it says a cubic polynomial function f is defined by f of x is equal to 4x cubed plus ax squared plus bx plus k, where a, b, and k are constants. So you treat them kind of just like coefficients. Like whenever I see a constant, I kind of treat it like a coefficient. So just so that like I know I'm not like solving for anything else. It's just a number essentially. And it says the function f has a local minimum at x is equal to -1. That's important. And the graph of f has a point of inflection at x is equal to -2. Okay, so it says to find the values of a and b. Okay, so the first thing I would do is, well, what first came to mind is it's only asking for a and b. So in order to get rid of k, you would essentially just have to take the derivative. And that's only because since k is a constant, the derivative of a constant is 0. So when you take the first derivative, that just goes away. So that's what I'm going to do first. So f prime of x. Okay, Julia, I want you to help me take the derivative of this just so you get practice. Okay, so what would be the derivative of the first term?
12x squared.
Yes. And then what would be the derivative of the second term?
2ax.
And then just tell me the rest.
Plus b.
Yeah. So that's kind of what you're left with. And then you're gonna have to use what's given here, like the point of inflection and the local minimum, to then kind of solve and simplify it. Because as you can see now, we have 3 variables, and we do not want that. We can't solve for a and b if there's 3 variables. So the first thing I kind of saw was you need to know that the derivative at a local minimum is 0. So essentially, f prime of -1 is 0. Yeah.
I don't get that. Can you say that again?
So when you're doing when f is a local minimum, remember when we're trying to find like the local minimums, this is a separate. We take the derivative and then we set it equal to 0. You remember that, right?
The number line?
Yes, it goes like, hand in hand with the number line. So essentially it's telling us that if f has a local minimum and x is equal to -1, then f prime changes from negative to positive at this point. And we also know that whenever there's a local minimum, the derivative is equal to 0 because it's just a horizontal line, right?
Okay.
So, and that kind of goes hand in hand with this little part right here. It's possible for there to be a local minimum when the derivative is equal to 0. So that's just kind of like a background. You don't have to do any of that for the problem. So, by this logic, it says that f has a local minimum at x is equal to -1. So we know that f prime of -1 is equal to 0 because if there's a local minimum at x is equal to -1, then when we did the derivative, when we set it equal to 0, we got -1 as a critical point, and that means that it was a local minimum. And you just need to know that. So, how I would solve, first. I would, since we know that f prime of -1 is equal to 0, if we plug in -1 into every single variable here, and let me just plug it in first. Yeah?
I still don't get how you know, that negative is like 0.
Well, you don't know that -1, like the coordinate that goes with it is 0, but you know that when you plug it in to the derivative, it's going to be 0, and it's because it's a local minimum. If you look back to like the theorems and like there's one thing you always need to know about relative minimum and maximums, and it's that the derivative at a specific minimum or maximum is equal to 0. So the fact that it's telling us that the local minimum is at x is equal to -1, we know that f prime of -1 has to be equal to 0, like it says right here. Like it's just like there's no like kind of, it's just a rule, I would say. And it's not like a formula or anything. It's just what's true about local minimums. And it's because if f has a local minimum here, it's like it goes back to the graph again. If f has a local minimum, and this is wrong, but it's scaled incorrectly, but if there's a local minimum there at this point, then the derivative, the tangent line, is going to be looking like that. And when you do a horizontal tangent, it's equal to 0. Does that kind of make sense?
Yeah.
It does?
Yeah.
Okay. And then the reason I'm telling you to plug in -1 is because we know this value right here. And then we can just kind of solve and move things around. So, sorry. Once we plug in -1 and simplify like everything here, that just becomes 12. That becomes -2a plus b. We know that this right here is equal to 0. So by doing that math, we can kind of just move things around. And what I'm seeing is that in order to make things like simple, I just moved the b to this to the what I did is just I moved the 2a over here and the 12 over there. So it just becomes 2a minus 12. That's what b is equal to. But as you guys can tell, like that's not complete because we need to know what a is in order to solve for b. So
12.
what I'm gonna do is go I'm gonna move on to the next part of like I'm gonna use the second part of what's given, and that will also help us figure out what it is.
Wait,
I
just
didn't Yeah.
can I just leave it at 12 minus 2a, or does it have to be 2a minus 12?
Well, it says find the values of a and b, and in order for you to get the full credit, you can't just leave it as a variable. You have to actually like solve and figure out like what it actually is, and there is a way. So that's kind of like what it's getting at. I think you would get some points just for leaving it that way, but you need to also like if you want to get full points, you would have to get like solve it completely. So going on to the next part, I'm gonna clear the screen and just I'm gonna write what we know at the top, which is that b is equal to 2a minus 12. After all this work, that's like the whole point. This is what we are trying to get, because we need to put it just in terms of a and b, because we can't have any x's, we can't have the f of x, we just need to get rid of that, and we did. So now I'm going to clear this, erase it, and we're going to move on. So, but I'm not going to erase the derivative that we just solved, because we know that f has a point of inflection at x is equal to -2. And if you remember, similar to the local minimum kind of reasoning, whenever f has a point of inflection at a certain point, we know that f double prime of that point is equal to 0. And since it says x is equal to -2, that's equal to 0. And it all kind of goes hand in hand with the first derivative test when you're finding the critical points, and then the second derivative test when you're finding the possible points of inflection. So does that make sense, Julia?
Yeah.
It does. And if you remember, like it will like and I'll send you my notes if you want, but that is just, it's always going to be true. If you know, and this is kind of harder to draw, but let's say that this is the graph of f prime, not f prime. If f prime is again, this is scaled incorrectly, but if f prime is like looking like that, the derivative, which would be f double prime, would be equal to 0. And this would mean that when you're doing like the regular graph of f, it would translate into a point of inflection. And it's different because now we're dealing with the graph of f prime and we're using it to, look at f double prime. So it's not the same thing as what we were doing before with the local minimums. Now we're moving on to points of inflection, but it's the same kind of logic on both ways. So I'm gonna erase this. It's easier to see with the relative maximum, but so now what I'm gonna do is, since we know that this is true, I'm gonna take the second derivative and then I'm gonna plug in what we know and then kind of did what we did before where we got it like in easy terms. So and this is actually gonna work out very well because we know that the derivative of 12x squared is just 24x, and the derivative of 2ax is just 2a. We know that f double prime of -2 is 0, so I'm going to plug in -2 so we can solve. And then you get that this is equal to 0, -48, and then that's 2a. And then if you move things around, you actually get that a is equal to 24. And that is already one of the answers. Okay, so if a is 24, by doing all that math, and the reason I took the second derivative was that another advantage of doing that is that it cancels out b, because the derivative of a constant is 0, so that works out very well. So when you finally get a, we can use this equation that we got before and just plug it in. So for b, I'm gonna try to fit it. So we know that a is 24, so we can just plug in a here and then solve for b. So that's 48 minus 12, and then we get that b is equal to 36. And then that's the complete steps for the problem. And that actually would have given you like a lot of points. If you know to take the first derivative, you know to take the second derivative, if you know that this is true, if you know that that is true, if you actually get the answers, that would have been like 5 or 6 points right off the bat. So that's how you do part A. Are there any other questions?
No.
No? Okay. So I'm gonna clear it. Julia, do you already have it like written down?
Yeah.
Okay. I don't want to like get too ahead. So for part B, and the point of this problem is just kind of like knowing how to manipulate the equation in order to get A, B, and K. Because like obviously since it's variables, they're probably gonna want you to solve it for them. So now if going to part B, and what I'm gonna write at the top is what we got in the previous equation, because now that we know A and B, we got that A was equal to 24, we got that B was equal to 36. This equation right here just becomes like a little bit more complete. So now I can write it as f of x is equal to 4x cubed plus 24x squared plus 36x plus k. So now it's like more number based, and I think having those numbers there, it just makes it more like digestible. So now we're going to go to part B. So if the integral from 0 to 1 of f of x dx is 32, what is the value of k? So the most important part of this problem, I would say, is doing what we had done right at the top. It's plugging in those values for a and b so that we can make things just more solvable. So if the integral from 0 to 1, okay, so basically what I'm just going to do is I'm going to integrate f of x. And using this new equation, not this one, using that, I'm just going to plug this in here. 24x squared plus 36x plus k. And we know that this is equal to 32, and that'll just be like our way of moving things around and solving for k eventually. So that's all I did. I just wrote it with the new equation, and then I also wrote this value here. Okay, so Julia, I want you to integrate this with me, okay? Like I want you to tell me each term like step by step. And I forgot the dx right here. And all right, Julia, are you there?
Yeah.
Okay, so the easy thing about this one is that there's no e of x, there's no ln of x, it's all just regular terms. So you can just go term by term by term, and then, you know, it'll be good. So what's the integral? And then the only other thing that you have to write at the end is that everything that we do is from 0 to 1. And then that's equal to 32. But that's just like regular stuff. That's just already given. So what's the integral? We're going to go by each term. What's the integral of 4x cubed?
X to the fourth.
4x to the fourth over,
4 over 4.
yeah, okay.
Cross them out.
The next one,
Okay. 24x cubed over 3.
next one,
36x squared over 2.
and then the last one.
It's just kx.
Yeah, okay, perfect. And then what I would do, you don't have to simplify it further. Oh, what were you going to say?
Because I wrote the first one as x fourth because I simplified it.
Oh yeah, you can actually do that. Like that's perfectly fine. Again, this would be all right, but we're asking to solve for k, and like I don't know, I think it's easier because we're eventually gonna have to plug in from 0 to 1, like, you know. So I think it's easier to simplify it like now. So that would, like you said, it would simplify to x to the fourth. This right here would simplify to 8x cubed. The next one would simplify to 18x squared, and then that's just k of x. I'm running out of space. Okay, so now it's from 0 to 1. And all I'm gonna do actually is just plug in 1, only because I noticed that remember it's upper minus lower, so it would be everything here, like it would just be plugged in with 1. So that would just be like 1 to the fourth, 8, 1 cubed, 18, 1 to the second plus k. Yeah, and that's what it would look like. But I'm not going to waste my time plugging in 0, only because every single term has an x. So if you plug in 0, it's just going to be 0. And then you're going to get the same exact answer. And then it's equal to 32. All right, so now it's actually just simplifying everything as best as we can so that we can solve for k. So this just becomes 1. This just becomes 8. This just becomes 18. That's just k. This is 32. And we're running out of space. I'm just gonna change colors. If you move everything over, so if you subtract 1, 18, and 18, and subtract it from 32, you're gonna get that k is actually equal to, and this may be clear if I do it like this. If you add those all those up, it's 27 plus k is equal to 32. And then if you move the 27 over to the other side, you get that k is equal to 5. Oops. Let me rewrite that. 32. And k will be equal to 5. And that's your work for that. And if you do all that, all those steps, I think you're gonna get full points. Do you have any other questions?
No.
No, you're good. All right, so I'm gonna clear the screen and move on to the next FRQ. This one only had 2 parts, but each part itself would give you a lot of points based on like all the steps you did. So that's kind of like where the majority of points would come from. All right, so now moving on to 2000 FRQ Q5. And again, this one is also more simple in the sense that it's just like a regular equation they give you, and it's more math concepts that are involved within them. But it's also a good practice for implicit differentiation. So that's why Ms. Q asked me to do problems like this. So the first part. So it just gives us a regular equation, and then it also it tells us to show that dy over dx is that. So that is the answer, but we just have to show, like, using implicit differentiation, that, you know, that is the correct answer for dy over dx. So we have to take the derivative of that and then use implicit differentiation to get this answer right here. So the first thing I'm going to do is just rewrite what's there. And then Julia, I want you to help me do this, okay?
Wait. Are we finding the derivative of like the top one of x squared of xy squared minus x cubed, like that whole thing.
Yeah, we're taking the derivative of that because if you remember, when you're doing implicit and we have x's and y's, I'm gonna just take the derivative of this term as an example. It ends up looking like this: y squared plus x, and then that's 2y dy over dx. And whenever you do take the derivative of y, this, that, because since we're all doing it with respect to x, and that's not an x, you have to write it like that. And
So why
if you notice, that's the same. Oh, what were you gonna say?
why are we taking the derivative of that if for a it's asking us to do implicit differentiation?
Oh, because it's asking us to show that dy over dx is that. So we have to use this right here, take the derivative, move things over, and do what we would normally do to show that that is the answer.
Okay.
So we're not taking the derivative of this, we're taking the derivative of this to show that that's the answer. That's what it's asking. And as I said, we're doing that because in order to get dy over dx, when we take the derivative, we're going to end up getting a couple of these, and then we're going to have to move things over and then do the rest. So that is the derivative for the first term. Because if you notice, since it's two variables, it's the product rule. So it's, in the product rule is the derivative of the first term times the second term plus the first term times the derivative of the second term. And by that, so the derivative of x is 1. I didn't write it. And then you bring down the second term, y squared, plus the first term, which is x, times the derivative of the second term, which is 2y dy over dx. Okay, next one. Julia, tell me or guide me through the steps.
Oh no, I don't know what you're doing.
Do you know product rule?
Yeah.
Okay, so what would be, do you know how to do product rule like with two variables?
I don't remember.
Okay, so remember product rule? Tell me the formula that you remember.
Prime of x times g of x plus f of x times g prime of x.
Okay, so then that's correct. So in this case, our f would be kind of this would be kind of the f, and that would be the g, like in the formula that you just told me. So what would be the derivative if it's like you said, it's f prime g plus f times g prime? What would be, like, help me plug in things based on what we have right here.
But like, okay, for the first one that you did, you left it at y squared because
Because there's a 1 in the front.
okay, and then
That's really bad, but it's a 1. Yeah, I'm just gonna leave it like that. So so what would be the first term that you would do for this, for the derivative that we're taking? What would be the f prime essentially?
oh, which part? I don't know. I'm confused.
For this, because we already took the derivative of this part right here. The yellow part we already did. Now we're doing it for the green. So now, like, we're just trying to figure out what would go here.
Okay, got it.
And
So,
so this is separate. We're gonna take what we do here and then I'll write it at the top. But so what would be the derivative of f prime?
3x squared.
Okay. And then what would just be g?
3x squared times y.
Okay. And then what I write now?
Plus x squared times 1. I mean
X cubed. X cubed
times 1.
times 1, but what are we forgetting? Because whenever we take the derivative of y, what do we also have to write?
Dx.
Yeah. So that is the answer. And what I'm gonna do at the top is just write what we did. So 3x squared y plus x cubed. And then I'm not gonna write the 1 because it's not necessary. And then that would be the derivative of these two. But then we also have to do this one right here. So that would just be equal to 0 because it's just a constant, right? Okay, so Now we have two terms that have dy over dx. So let me erase this. And I'm just gonna write the next step that I would do, and it's just to distribute the negative that's right in front of it, right here. We have to distribute it. Oop. Yeah. Sorry. We would have to distribute this negative right here. So I'm just gonna rewrite it. So it ends up being y squared plus 2xy dy over dx minus 3x squared y minus x cubed dy over dx is equal to 0. Okay, so we want it to look like this. We just want it to be dy over dx. But in order to do that, like, and this is kind of what Ms. Q like taught us to do, we want to end up just with one side with dy over dx, and then the other side with no dy over dx. So what I'm gonna do, and the reason we're gonna do that is because we want to end up having it like in the front so we can divide. And you'll see like what I'm talking about, because it's kind of harder to picture unless it's like right in front of you. So what I would do is I would just move everything that doesn't have a dy over dx attached to it to the other side. So I'm going to rewrite this. I'm leaving everything with dy over dx on one side, and everything that does have dy over dx, so 3xy squared minus that. So we move this one and this one to this side. And now it looks like this. Do you understand what I did, Julia?
Yeah.
Do you understand? And then do you understand that now, because we did that, we can move the dy over dx to the front, and then it looks like that?
Yeah.
And now that we have it in the front, we can divide by, let me just finish writing it actually. We can divide by this on both sides. And if we do that, it's gonna be 2x y don't space. So what I'm gonna do is actually I'm gonna erase the top, and then I'm gonna write it here. So, and just not to get confused. So no, little line. So what I want to do now is, now that it's in terms of now that there's a dy over dx in the front, we can divide by what's on the right here on both sides. So when we do that, we end up getting a dy over dx is 3x squared y, 3x squared times y minus y squared over 2xy minus x cubed, which, it's a little weird. So if you look at what it told us to prove, that's exactly what's there. So we show, by doing all these steps, we prove that that's the right answer. And then that's how you do part A. Does that make sense?
Yeah.
Okay. So now moving on to part B. So part B, let me just double check. Part B asks, and it says part B, to find, okay, I'm gonna clear this and then move on. It says, find all points on the curve whose x-coordinate is 1, and write an equation for the tangent line at each of these points. Okay, so for this part right here, we just need to show, it says to find all the points on the curve whose x-coordinate is 1. So remember that a coordinate, it involves an x and a y. Oops. So a coordinate, you need an x and a y in order to get credit for a coordinate. And it's telling us that this coordinate will have a 1 in it. So all we have to do now is solve for the y, right? Because that's all it's asking. So that we're just gonna do the first part first. Find all the points on the curve whose x-coordinate is 1. So in order to find the y, all we have to do is just plug in 1 into the original equation. And by doing that, we find the y value that goes with each x, kind of like how you do it with a normal equation. Okay, so that just becomes y squared. That's minus y is equal to 6. I'm seeing that if I move over the 6 over here, it becomes a polynomial, which, as we know, we can factor. So what would be the factored form of that, Julia?
Oh God.
You're good.
Y minus 3y plus 2.
Yep, perfect. Okay, so now we know, and then what would that mean? That y can be equal to what?
Y can
There's
be
2.
y can be equal to -2.
Perfect. Okay, so we've now at this point we have our x and then we have our 2 y's. So I'm gonna erase what's at the top, and now we know that our coordinates, since there's 2 y's, that means that when you plug in 1, you can either get 3 or you can get -2. So it's gonna be either 1 comma 3 or 1 comma -2. Those are our coordinates. We're good. And all right, so now that we have the coordinates, we've done like the first little part of the problem, and now it says write an equation for the tangent line at each of these points. All right, so I'm gonna clear or erase what's here, so there's room to do that. And if you remember, when we're doing an equation of the tangent line, and for this problem we have to do 2, since there's 2 coordinates, we have to have sorry, let me keep erasing. We need to have a point, which we do. We have 2 points right here. Oh, God. Don't know what happened, but let me just share it with you guys again so that there's that. All right, so if I remember, we had coordinate here. We had that it was 1 comma 3, 1 comma -2, and I was saying when you're doing tangent line, you have to have the point, which we have here, and then we also have to have the slope, which is the m. And what would be the slope, or how would you find the slope, Julia, of a certain point?
You do y squared minus y2 minus y1 over x2 minus x1.
That would be like the average slope, but if you're trying to find the slope at a certain point, what would you have to do? What is it?
The derivative.
Yes, and the derivative is dy over dx. That is the derivative. The derivative can be written as like f prime, or it can be dy over dx. Those are the 2 most common. And if you remember from part A, we proved that dy over dx was equal to, and it's 3x squared y minus y squared over 2xy minus x cubed. It's all of that. So what we're gonna have to do in order to do the tangent line is we have to use the point we got, but then we also have to find the slope at that point. And we're gonna have to do that by plugging it in both times into this function right here. So that's what I'm gonna do first. So at the top, just so that because I know I'm gonna have to erase eventually. So when we're doing the tangent, which is gonna be the last step of this part, we're going to need, and let me just write tangent here. So for tangent number 1, we're gonna use 1 comma 3, and we're gonna find the m, which is what we're gonna do when we take the derivative. And then for tangent number 2, we're gonna use 1 comma -2, and then I'm gonna write the m at the top, and I'll write it there. So that's what we're gonna do. And just because I know I'm gonna have to clear the screen, and yeah. So dy over dx, when you plug in And the first one I'm going to plug in is 1, 3. So you write it like this. You draw a line, and then you write the point you're plugging in. So you plug in, every time you see an X, you plug in a 1, and every time you see a Y, you plug in a 3. So I see a 1, I see a 3, I see another 3. I'm seeing, that's 2 times 1 times a 3, and then times another 1. And then that becomes 3 times 1 squared times 3 is 9. And then 3 squared is 9. And 2 times 1 times 3 minus 1 is 6 minus 1, yeah. And then that just becomes 0 over 5, which is just 0. So we know our m right here is 0, because we just proved it. So now I'm going to do the same thing, but I'm going to do it for our little number 2. And that's 1 comma negative 2. So let me erase it. And then I'm going to do the same thing for that point. So now dy over dx, when it's 1 comma negative 2. All right. So I'm gonna do the same thing again. So whenever I see a 1, whenever I see an x, I'll plug in a 1. But now whenever I see a y, I'm gonna plug in a negative 2. So that's how it's gonna look, like that. And then on the bottom, it's 2 times 1 times negative 2 minus 1 cubed. And that simplifies to negative 6, because 3 times 1 squared times negative 2 is negative 6. Minus negative 2 squared, which is minus 4. That's a negative 4 at the bottom. And then that's also minus 1. Okay, so that simplifies to negative 10 over negative 5, which is just 2. So now we have that m is equal to 2 there. Okay, so now that we have our 2 slopes, we're just going to do point slope using the point that we got and the slope that we just got. And that's how we're going to write our tangent line. So let me just erase this so we can do that for each one, since we have to have 2. So Julia, can you help me write those?
Okay, so
Let me just draw a line just so that because since we're doing 2 tangent line. So it would be, and remember, it's y minus, and then just tell me what to write.
y minus 3.
Yeah.
0.
And then, okay, so that's y minus 3, but since there's a 0 in the front, what does that do?
It's 0, so then it'd be y equals 3.
Correct. And that's all you have to write. And then how about the second one?
Y plus 2.
Correct.
X minus 1.
And then all you really have to do here is just move over the 2, because I usually like it in terms of y. But even then, I think if you just write that, you'd be good. But yeah, that's how I would write it. Just y is equal to 2, x minus 1 minus 2, and then you're good. That's the answer. All right, so I know that one was like a little long, but yeah, you do have to do all those steps in order to get full credit. And then I think as long as you write like either in this form or if you write like that, I think it'll be good. Okay, so now moving on to part C, and then we'll be done. Part C. Find the x-coordinate of each point on the curve when the tangent line is vertical. Okay, so if you remember, whenever you have a vertical tangent, you need to know that the tangent itself does not exist, right? Because this is just an example. When a vertical tangent occurs, it's kind of like this. And the tangent, I'm going to do it in yellow. It would be like kind of like here. But you can't have a vertical line, because a vertical line means that your slope is like a number. I'm going to write, let's just call it 2, and then it's over 0. That's what it means. Whenever you have a vertical slope, or whenever you have a vertical tangent, your slope kind of looks like this. and that's why it's undefined. It's undefined or does not exist. Yeah, whatever. That's why it's not there. You know, it's not real. So by this logic, and then I'm gonna write the derivative at the top because it's asking where the tangent line. And you know the tangent line is the derivative, and we know that the derivative all the way back from part A is 3x squared y minus y squared over 2xy minus x cubed. All right. So Julia, by using this logic, like right over here, what would have to be true in order for this to be vertical?
I don't even know. I don't know.
Like, and it kind of goes with this logic right here. The denominator will have to be 0, right?
Okay.
Does that make sense?
It has to equal 0.
Yes, because think about it. When the denominator is equal to 0, or I'm talking about this part right here, the line will have to be vertical because anything over 0 is undefined or does not exist. So by doing that, by setting this equal to 0 and finding when it's equal to 0, you know that the tangent line itself will become vertical.
You have to make the denominator equal to 0.
Wait, can you say that again? Sorry, you broke up.
You have to make the denominator equal to 0.
Yes, because vertical tangents occur, and it's in the yellow, like I was saying. Vertical tangents occur when it looks like that, and that the slope of that line would just be a number over 0. So that means that for here, in order for this to become vertical, the bottom would have to be 0. So 2xy minus x cubed would have to be equal to 0. Does that kind of make sense?
Yeah.
Okay. So now that I've set it equal to 0, we have to solve for, and it says to find the x coordinate, right? So, this is kind of tricky, and there's many ways to do this, but this is kind of how I saw it. So I factored out an x right here, because now we know that by using this, we can know that x is equal to 0, and now we know that 2y minus x squared would be equal to 0. And then also by that logic, it would just mean that y is equal to 1/2 x squared, because I move over the x squared to the other side and divide by 2. So it's 1 over 2 x squared. So we know that at this coordinate and then at this coordinate, dy over dx will be equal to 0, the denominator. So that means it'll be vertical. Okay, so what I'm gonna do, it's kind of messy, so I'm just gonna rewrite everything nice here at the top. And now that we know like the 2 points that it could happen, and the this one right here actually is kind of not proper. It's not in the right form, but we can put it in the right form only because we can plug it into the original equation and then get like the correct way to do it. So we know the derivative, I'm gonna rewrite it again, is 3x squared, 3x squared minus y squared over 2xy minus x cubed. And then separately, we know that x can be equal to 0, and we know that y is equal to 1/2 x squared. And now, since this is not like a regular equation, all I'm gonna do is plug it into the original. I'm gonna plug in x is equal to 0, and then I'm gonna plug in y is equal to 1/2 x squared into the equation and just see if it works out. See if there's actually a value that gives me the correct tangent. I don't know why that happened, but okay. So now we're gonna try it with this one, and then we're gonna try it we're gonna try it with this one, and then we're gonna try it with that one. So let's do it for both. Okay, so when we plug in x is equal to 0 into the equation, we get that. I'm just plugging in a 0 whenever I see a 0 in the equation. We get that 0 is equal to 6. That's not true. So you can eliminate this as a possible point where the vertical tangent is where the tangent is vertical. Okay, so then what about for the other one, y is equal to 1/2 x squared? So then now what I'm gonna do is I'm gonna plug in 1/2 x squared whenever I see a y. So x, it's 1/2 x squared minus x cubed, and we're almost done. Sorry, no, this is boring. So after doing that, now we can solve for x. And remember, we're asking for an x coordinate. And this is just a side note. Y is equal to 1/2 x squared can also be written in terms of x. And if you do it, it becomes actually x is equal to plus minus radical 2y. There's two ways to write it. And if you plug in either way, I think you get the same answer. But since it's asking us to solve for the x coordinate, and by plugging in y, you're just left with x's, x, x, x. I think it would just be easier to get the x directly. So that's why, and you can do it this way or this way, but I think I'm doing it this way only because I just want the answer right away. I don't want any more manipulation. So that's just a side note. Oh, okay, there. Wait, stupid. So there. All right. So now that we've plugged in, all we have to do is simplify. So it's x 1/2 x squared. Squared becomes 1/4 x to the 4th minus x cubed. That's just x cubed times 1/2 x squared. So I'm just gonna write it as 1/2 x to the 5th, and then that just is equal to 6. So then this just becomes 1/4 x to the 5th minus 1/2 x to the 5th. When you combine those, you can write it as 1/4 x to the 5th minus 2/4 x to the 5th is equal to 6. So then you're left with, wait, give me a second. You're left with negative 1/4 x to the 5th is equal to 6. I'm going to multiply by -4 on both sides. And I'm just going to continue up here. So then you're left with x to the 5th is equal to -24. And now I'm going to take the 5th root on both sides, and I get that x is equal to the 5th root of -24, which I'm not going to simplify or attempt to simplify. I'm just going to write it like that. So yeah, and that would just be the answer, because it does end up working out. Like, we plugged it in and we got an x value, not like this one where we plugged it in and we got an inequality, which is not true. Like, we actually got an answer this time. So then if you just kind of circle this, it shows that you know that's like the right answer, and then you just like cross off that. All right, so that's the last part. Julia, do you understand?
Yeah, I do.
You do? All right. So that's the last part of this FRQ. So we just did 2001 and 2000 Q5. So that's just 2 problems out of the way for Miss Q's homework. And then we'll continue next week. And then those will be our 2 last sessions, because the test will be on Tuesday the week after. So we have essentially one more week until the AP test. So let's just practice as much as possible before, and then I think we'll all do good. Does anyone have any other questions? And you guys just know, like, if there's ever a question, just just text me and I'll help you guys out.
You giving us a test like anytime soon?
What?
Like, is she giving us a test? She didn't give us a test last week.
She said that she wasn't gonna give any more tests. So
Okay.
I'm just assuming that she's I think she said something about using the AP exam. I don't know. I think she said she's gonna use the AP exam to help us out with our grade. Like, if we do well, she'll change our grade. I think that's what she said. So, if now that that's just more at stake. If you do well, she'll actually help you out. But if you don't, I don't know if she will. I think she might help you a little bit, but I don't know. So that's it. And just know, I hope you guys have a great day. Bye. Bye everyone.
Thank you.
Bye.